Thank you very much for your introduction, Ogawa Sensei. So today I'm going to talk about the NDT of CFRP and application issues for high pressure composite pressure vessels for fuel cell vehicles. And this is the outline of today's presentations. And let me start from possible damages caused in CFRP. But firstly, let me remind you type of damages caused in metal structure, not CFRP, but metal structures. There are plenty of fracture modes, such as fatigue, stress corrosion cracking, erosion, or welding defect. But all these plenty of damage modes can be simply modeled as crack or thinning or void. So this kind of the damage can be easily detected by general NDT method. For the viewpoint of the NDT method, for let me say the UT, fatigue or stress corrosion cracking, it don't mind. For UT, this is just crack. And talking about the crack or thinning, this kind of the damage mode can be predict development during in service. So we can estimate how long this crack propagates after 1 year by using the fracture mechanics. So easy to estimate the remaining life. Okay, so let's talk about the fracture modes caused in CFRP. So this is some example caused damage mode caused in CFRP. There is fiber fractures, transverse crack, matrix crack, and also fiber waviness. So very complicated and very complicated. Okay, so let me talk about the difficulty of NDT for CFRP. So what makes it difficult to the NDT for CFRP? So there are several causes. So first one is, okay, so NDT methods have not been established for some damage modes. So we can have the NDT method to detect the delaminations, but I can say that no good method to detect the fiber breakage, single fiber breakage. And first reason is the detection target cannot be simply modeled as crack-like or thin wall defect. So like this one. So compared to the metal materials, we cannot simplify the damage mode like crack or thinning or void. So second reason is, depending on the type of fracture, smaller defects can affect the overall structural integrity compared to the metallic materials and requiring more accurate inspections. So for example, fiber breakage, this one, is very small defects, but large effect of the structures. So we need to detect fiber breakages by NDT in some cases. And the difficulty is not only detecting the presence of discontinuities or wall thinning, but also need to evaluate damage modes. So this discontinuity is from fiber breakage or transverse crack or delaminations, we need to distinguish. So this kind of the distinguish is required as the modes, fracture modes greatly affects the structural soundness. And also difficulty, so this is not a difficulty of NDT itself, but bottleneck damage mode for structures varies depend on the loading method, just tension, load, or bending, and also loading directions. And also even same loading, when we change the stacking sequence, stacking configurations of CFRP, also bottleneck damage is changed. So that is the difficulties. So this is example. You can see delaminations here. As you know, when we just apply the tensile load, these delaminations not affect for the structural integrities. But if we apply the bending, then these delaminations cause reductions of the structural integrity. So this is the difficulties of the NDT for CFRP. And code 3 and 4, we going to talk about later in details, but this third one is ultrasonic waves are bent due to mechanical anisotropy. And this 4 is the current path. When we do the eddy current, the current path is changed due to electrical anisotropy, also a stacking sequence. But I'm going to talk these topics later. Before talking about the applications, I'm going to introduce the method to assure structural integrity by NDT. So in generally, firstly, we identify the possible external forces acting on the CFRP structures. So if some customer ask me to do the NDT, firstly, I'm checking what kind of the external force acting on the CFRP structures. Sometimes bending, and sometimes, some cases, some force is accidentally, so like the impact is caused, attacked to the on the surface. So we think about the all possibility to cause to the CFRP structures. And then assume damage mode that may occur to the CFRP structures by these external forces. So let's say when impact is occurred, then this kind of the damage mode is occurred. And then external extract dominant damage mode that may reduce the structural integrity. So this is a combination of the what kind of the external forces is caused in the structures and what kind of the damage mode exists. So if bending external force, bending moment is applied to these structures, then delamination is the dominant damages to reduce the structural integrity in this case. And for the extracted damage mode, in this case delamination, then consider the size of the damage to be detected by NDT, and then select the suitable NDT inspection method. And if there is no method, we need to develop a suitable new NDT method. So today is a research forum for lightning resistant metal coating, and I want to discuss about the what is the major damages. So I think delaminations and fiber breakage in aircraft, and I want to know possible NDT method. So now many researchers introduce ultrasonic testing, and X-ray. But I want to discuss about another possibility, another NDT possibilities. Okay, so let me explain introduce some development applications of NDT for composite. So let's go back there are 4 programs for the NDT for CFRP, and this code 3 is the ultrasonic waves bent due to mechanical anisotropy. I'm going to explain these topics. So there are several structures with the carbon fibers which is curved like this one. And in this kind of the structures, carbon fibers is also bent along the structures like this. And sometimes manufacturing defect is caused at this corner. So companies do the ultrasonic testing to detect manufacturing defects. So this is collaboration research with the companies, and this company previously make this mechanical parts by metal materials and do the inspections of the corners defects by using the ultrasonic testing. But when they change materials from metal to composite carbon fiber reinforced plastics, they cannot detect manufacturing defect at the corners. So they ask us to do the collaboration research because they want to know the reason why they cannot detect this defect. So firstly, we do the simulations, ultrasonic propagation simulations. And as you know, this is a simulation result for the isotropic materials, aluminum alloy. When ultrasonic is generated, ultrasonic propagates like this. But we found that if there is a carbon fibers, like curved fibers along these curvatures, then you can see that when ultrasonic is generated at here, ultrasonic propagates along carbon fibers. So it's like the light in the fiber optics. So then this is the reason when we generate ultrasonics, then ultrasonic propagates along carbon fibers. So no reflection is come back to the transducer. This is the reason. So we propose method to detect the damages in CFRP composite with curved fibers by using the phased array and controlling the ultrasonic propagations. So if we just generate ultrasonic from the probe, this is the propagations, ultrasonic propagations, and if this is the assumed crack locations, crack direction is this directions, then ultrasonic cannot propagate directions is not perpendicular to the crack surface. So in this case, very weak reflection is come back. So it is not suitable. And if we control the ultrasonic generations, as you can see, ultrasonic propagation directions become perpendicular to the damaged surface. So strong reflection can be obtained. So we need to control ultrasonic propagations when the carbon fibers in CFRP is curved. So another application is this is a problem. So when we do the eddy current testing, the current path is changed by the stacking sequence or due to the electrical anisotropy of the CFRP. But today I'm going to show you some application if we use this kind of the effect, we use this phenomena effectively. So this is a composite materials, carbon fiber with phenolic resin, not epoxy resin, phenolic resins. And this composite material is used for inner side of nozzle of solid rocket booster and used as aberrator. And generally, this composite material's thickness is reduced like this. I mean, the general erosion is occurred by high temperature gas. But if there is a waviness, this one, fiber waviness, inside of the composite material, then local erosion is occurred like this. And if local erosion is occurred, some part, thickness of the some part reduced drastically. So we need to detect fiber waviness in this composite. But as you know, the diameters of the carbon fiber is very small, so it is very difficult to detect this kind of the fiber waviness. Firstly, we tried using the ultrasonic testing, but we cannot detect this one. So we do the brainstorming with students, and one student says the carbon fiber is electrical conductive material. So electrical current should flow along fiber. So if we can visualize current flow, then we can detect this kind of the waviness. So we make some special eddy current testing systems manually made by students, and put the driver coils here, and this two driver coil is used for induce eddy current, and this one is for pickup. And this is the image of the testing. When fiber is straight, then eddy current path is also straight. And the magnetic field is caused vertical to this current path. And if we put the pickup coil in these directions, no signal is obtained. But if there is a fiber waviness like this, then current path is changed. Also magnetic field is changed. Then this pickup coil gets some signals, and we can recognize that there is a fiber waviness. And finally, we make some softwares and can visualize the fiber waviness like this one. Okay, finally, let me show you some new project, NDT for hydrogen jointed pressure vessel for fuel cell vehicles. So fuel cell vehicles, FCVs, need to become more widespread in order to reduce carbon dioxide emissions. And when hydrogen pressure vessels can be made less expensive, now this kind of the vehicle is very expensive. So if we can make less expensive, the price of the FCVs, sorry. So if we can, so there are 3 pressure vessels in the FCVs now. So if we can reduce the price of pressure vessels, then we can make the price of the FCVs more less, and leading to their widespread use. So, and the price of the vessels can be reduced if the amount of carbon fibers used is reduced. So if we can make the thickness more thinner, then we can reduce the price of the pressure vessels. So this is an image of the conventional pressure vessels manufactured by filament winding method like this. And you can see the thickness at this part is very thick because fiber bundles that are not, okay, so fiber bundles that are not necessary for strength are used as a vessel is made by winding a single carbon fiber bundle. So when we winding, and every time we need to return at this corner, then thickness at here become very thick. So idea is we change to the fabrication, so we make the jointed vessels we call. So this is a jointed part. Then we can reduce the thickness at here, also cylinder part, by separately manufactured and joined. And also, if we do the NDT, then safety factor can be reduced. So now the tank is made by safe life design, but we change the design concept to damage tolerance design. Then we can reduce the safety factor. So now, okay, current integrity assurance of hydrogen composite tank is shown here. So regardless of the environment, regardless of the pressure histories, the structural integrity is guaranteed without detailed NDT. We don't do detailed NDT now. Only by high safety factors and replacing it after 15 years. But now we want to try to change like this. So the maybe near future, all vehicles become the connected cars like this. So it's become capable to monitoring the usage of environment, how many times they filling the hydrogens or pressure history, something like that. So we can easily to monitor. And also we do the inspections during the hydrogen fillings, like this one. So during the hydrogen filling, we do the acoustic emission testings, and also using the ultrasonic guided waves, and we do some simple NDT. So we say that, is it? Yeah, this one. So we say convert hydrogen stations into Formula One's pit stops, like this one. So during the filling, not only the filling the hydrogen, but we do the inspections. And then, okay. And we do some national projects, NATO projects, and this is our groups. I'm the leader of this project, and also Uchimoto Sensei from Tohoku University is attend this project. And firstly, so today I'm going to introduce some from this project. First is the ultrasonic testing for the joint part. So when we needed to inspect the joint part of the pressure vessels, but this bonded area, bonded surface is inclined. If we put ultrasonic probe on the surface, reflection waves not come back. Then we need to control the angle of the incident. But some difficulty is, this is a CFRP. So wave velocity is changed by directions. So if we decide this incident angle, we need to also consider about the change in the velocities by angle. So we develop method to determine this incident angle, and we do the inspections, real inspections. So firstly, we make some model specimens like this one. This is the joint part. And firstly, if we just put the probe, ultrasonic probe on the surface, then this is the result. This is the reflections from bottom surface like this one. But if we want to monitor the ultrasonic from a joint, this one, but we cannot see if we just put ultrasonic on the surface. So if we change the incident angle like this one, then as you can see, we can get a large reflection from the joint, and reflection from the bottom is disappeared. So, but we found that if we incline this angle, we can check the bonding areas. Okay, another method is, as I said, we wanted to do the acoustic emission testing during the fillings of the hydrogens. but we needed to change the tank designs to the damage tolerant designs. So I mean, just a moment. Okay, so make the tank not rupture, even all fibers in few layers break. So we change the tank design, and we obtain the fiber breakage by acoustic emission testings before rupturing. And we make some optimization method for stacking sequence to maximize the damage tolerant abilities. So now we can maximize the damage tolerant abilities. Okay, and finally, maybe next presentation by Uchimoto sensei, maybe he is going to introduce eddy current testing result by using some robot. And this robot is made by Tokyo Tech, and this Prof and analysis method is made by Tohoku University. So we do the joint research. Okay, so conclusion is today NDT testing of CFRP and application issues for high pressure composite pressure vessels is introduced, and hope that appropriate NDT inspection method and remaining life prediction technique based on NDT result will be developed for lightning damages. Thank you very much.